All right, so welcome to today's class, March 23rd. Um, so today we're going to be doing a lab. So if you're logging into the stream after it's been recorded, you should pull up the lab right now, kind of pause and look at that. So the first thing we have to kind of look at is this group participation survey that I want you to wait till the very end to fill out. So I do want all of you to try to do this in a group still, 3 to 4 people. I want you to try to communicate through either text or video chat. I'm pretty sure you're able to start up a Google Meet just like this one. It's rather straightforward. You just go there, start a new meeting, name it something, and then send someone the link, or just any sort of communication you can do. So the survey just kind of says how each person participated. Now you write the person's name, their role, and I want you to rank them from 0 to 10. Now, it's not like a normal 0 to 10 where 0 bad, 10 good. The goal is everyone participates equally. So if everyone participates equally, everyone gets a 5 right in the middle of that. So if someone has less than a 5, they did less than their share of work. If someone has more than a 5, they did more of their share of work. So if you say someone did a 10, that means they did way more work than they needed to, and someone else should have a 0. So kind of the ideal thing is everyone gets a 5 by the end. All right, so we're going to do a little bit of simple harmonic motion for this lab, just kind of based on the things I have. So if you look at the lab, that's why I have all of these different masses of coins. For today's lab, we're going to be using nickels. So we have right here, the average mass of a nickel is 5 grams. And then the mass of the hanger, I made a makeshift setup. So the hanger's mass is going to be the mass of 2 dimes and 1 nickel. So let's write that here. And my screen is inverted and I can't change that and it's obnoxious, but we'll just deal with it. So we have mass of a nickel is 5 grams. And the other one, mass of a dime, is going to be 2.268 grams. And then we're going to be hanging all of this inside of a container that I put together. And the container, I made a little balance to kind of compare it to the other masses. So the hanger is about the mass of 2 dimes, 2 times the mass of a dime, plus 1 nickel. All right, so that's going to be up to you to figure out how much mass each of those are. All right, so why is my video frozen? There you go, you're not frozen anymore. All right, so we have this set up here. I don't have any springs that I could use well. I tried, but they didn't end up working out. So we're just going to be figuring out the elastic constant for this rubber band first. All right, so we're going to find this elastic constant. So the first things first is we need to figure out where our equilibrium position is. So let's kind of look here. And my video is reversed. So the equilibrium position is going to be somewhere right here. Let's look at the bottom right there. So that lines up right about with that 5 centimeter mark. So you'll record the 5 centimeter mark. Now we're going to go through and I'm going to add different amounts of nickels, probably going to add 5 nickels per time, and we're going to see how far this moves. There you are. Actually, maybe a little bit more. think we have enough to add more than that. Let's add 8 at a time. All right. Now we've added 8 nickels, so we have our new position there. So try to read the position from there. All right, then we'll keep adding. I'll add 8 more. 2, 4, 6, 8. Our new position with 8 more nickels. So we have 16 nickels in there right now. All right. 8 more. This is our new equilibrium position with 24 nickels in there now. And by the way, if you're wondering, the hole on the board caused by one of these magnets. These are rather fun magnets. I think it's something like when you get 2 of them together, they have a pull force of like 300 pounds or something. 8 more nickels. Could you get a nickel? From somewhere, just don't go out to get one. Oh yeah, backwards. All right, so this is with 32 nickels. Record the value. We'll add 8 more. So I think the last one I said was 32, so this is 40.
Mr. Beverly, are we using your numbers?
Here's what I would say about.
What do you mean? Yeah, you're using my numbers, yes. And then this is the last amount. So this is the last number. What was that? 48 nickels. To the bottom right here. All right, can I repeat the numbers? All right, yeah, we can go through that one more time. I wish I had some sort of stand to do this nicely, but I don't. Yeah, if I zoom too far out, can't see that too well. All right. So yeah, starting right here, we're at this position with 0 nickels in here. 1, 2, 3, 4, 5, 6. 0 nickels. This is 8 nickels. 16. $32. $40. $48. And then 56 when I pick up the 2 I dropped. And then this will be 56. All right, so again, when we do this, we need our distances from the equilibrium position. So you're not just straight up recording the numbers written on the side. You need to figure out how far away we are. When you record the positions, you can just write that under data. I don't think I ever explicitly said write it somewhere. So yeah, that we're on part 1, number 1. Now, when you do this, I suspect you're going to get a graph that's not linear. For everyone, try to find the range where it is linear and try to evaluate that. I'll give you some bonus points if you evaluate it based on the curve, but most people, we're just going to find a place where it's relatively linear, and that's where it's behaving like a Hookean spring. So all of these, you can just write it out on a piece of paper. So as long as you get all these points, it's fine. You can just make your own data table where you show a number of nickels, so like 0, 8, 16, 24, and then the position. And then you can also record how far it's moved from equilibrium. And I don't expect this to be perfect, so just do your best. All right, so you're going to use those values. You're going to record your position, and you're going to record the mass of the nickels. The whole goal, obviously, of this is we want to get a graph. What type of graph are we going to create where the slope is our spring constant? So what 2 quantities do we want to graph to get the spring constant?
Displacement.
Displacement is one of them. So how far we move from equilibrium, what's the other one?
Elastic constant.
Well, elastic constant is what we want to be our slope.
Email me with any concerns or questions using your GIS.
So what's the other?
Mass.
Emailing me.
Mass. We're not going to measure mass, though. We have our free body diagram. Weight. So we have our, we're going to still call the spring force, even though it's elastic force. So the weight is going to equal the spring force. So we're really wanting to graph our spring force. So when I graph this, I have that spring force is equal to spring constant times displacement from equilibrium. So which one of these am I going to put on the y-axis? All right, so we're going to put spring force, y equals mx. So spring force we're going to put on our y-axis, displacement on our x-axis. And you're going to use this to try to figure out the elastic constant, so that should be your slope. And then try to think about how we're going to do this in order to get our spring energy. So what are we going to have to look at to get the amount of energy stored? Yeah, this next part is going to be a little bit challenging. We'll do it anyways, though. I don't know how well this next part is going to work out. But at the end of the day, it's partly just to get you practice doing the work. So this next graph might not work out perfectly, but as long as you get a graph that should show the value, I'm happy with it. Good morning. Any questions about part 1 and the data you gathered before we go on to number 4 on part 1?
So the mass of the hanger, like the 2 dimes, 2 mass dimes plus 1 nickel, that's just a container without any coins in it, right?
That is the container without any coins in it, yes.
Awesome, thanks.
You're welcome. Here, I'll be right back. When did you answer? Where we check position. What do you mean? Last question, where we check position. What do you mean by check position? So the position you're getting from the videos. 2B. All right, so yeah, that's where we're going to create the graph. And just think about it. What are the two things we can look at on the graph? What are the 2 ways we can analyze a graph?
Area and slope.
Area and slope. So we looked at slope because y equals mx. What are we going to need to do in order to get the amount of energy stored? Area or
Square the
slope?
position. Square the displacement.
What's that? Oh, which part of the material is at the end of the box? So it doesn't really matter. I was trying to line it up to where you could see the bottom of the container easiest. So yeah, I would look at the bottom of the container. It doesn't matter. Anywhere on the container will work. So if you use the top of the container or the bottom of the container, you could use the middle. It'd just be hard to be consistent. But yeah, just anywhere on the container you can use to find the position. Well, so we already looked at area, or slope, so let's look at area. So if I do area would equal base times height. Hopefully for part of this graph, you should get some sort of a line. So if I do area, let's say like 1/2 spring force times the distance. Well, spring force, I know is spring constant times that displacement from equilibrium. So 1/2 times spring constant times displacement from equilibrium times displacement from equilibrium, or 1/2 displacement times that, or spring constant times the displacement from equilibrium squared. And what does that look like?
Here to answer.
That looks like spring potential energy. So that's the goal. You're probably not going to get a nice straight line like this. I'll let you figure out the region where it is relatively linear, and we're going to pretend it extends out from there. For some of you in calculus, you can try to do some sort of, I don't know exactly what that's going to look like. It might be some sort of linear spring constant, which would mess up your graph. We'll just do the best you can. I tried to get some springs, but the springs didn't end up working out. What were the positions? I don't know off the top of my head. You can look back through those in the video, or if another member of your group got it, you could share that. All right, any other questions before I do number 4, where we try to figure out some of the periods of oscillation? Part 1, I mean, I didn't do all of it for you. You have to go in and fill out the data, but I've talked about 1 through 3 on part 1 so far. Now we're going to do the procedure for part 4 of part 1. Number 4 of part 1, sorry, I should say that. All right, so number 4 wants us to find the period of 6 different masses on the same spring. And it wants us to create a linear graph that can be used to find the spring constant with this data. So this is kind of the challenge question that I want y'all to really think about. So I'm not going to directly tell you the answer to this one. If you still have more questions about it, then I can talk about it in tutorial. 2b. Yeah, 2b, you're just going to calculate what it should be as opposed to actually testing it. So 2b, you're just calculating what you think it should be. Yeah, 4, I don't think we're going to be able to do 6 of these. Probably a few less. That's all right, though. All right, now we're going to be looking at our period. I'm somehow going to keep my phone away from these magnets while we do this, otherwise they could destroy my phone pretty easily. All right, so I don't have enough hands. I don't know what I was imagining. I guess I was imagining I had like an additional hand when I did this. Put the phone in the container. I'll be right back.
I'm the teacher now.
Anybody have all the different masses and lengths of the rubber band?
All right, so we're gonna have a running timer in here. Now, when you look at this, I'm gonna pull it down and let go, and you'll watch it. You're going to see it pretty quickly dies down. So you're going to want to do for the first like oscillation or two. Let's see. All right, so I'll let go. And then you'll get the time for it to go up and then return back to its original spot for the first time. You're probably going to have to look back to this video to do it. I'll try that one more time. So I'll let go, it'll go up and return down. So. What's off? Too laggy to tell. Yeah, you're not going to be able to figure this out in real time. You can't, can you not see the timer? What do you mean it's off? I am just on audio. What is wrong with this? It's showing up on my screen on my laptop. Can you see it now? Was it just when? Yeah, I think the entire video is recording. So we're just going to go through these. Oh, the timer wasn't completely showing. Can you see it now? Does it just stop recording when I go vertical? I guess that's what happens. It doesn't like it when I go vertical. Well, isn't that obnoxious? So let's... All right, so you can all see this. We'll look at this paper clip. So that was one little shot if you couldn't see that. Let go. I don't think my fridge is really short. I think you're just not used to looking at fridges from my perspective. I'm able to see on top of most fridges. Yeah, just like most counters, like this is my view down on most counters. It's actually really obnoxious because I have to like bend over a lot, then my back hurts. All right, so that last one was with 16 nickels. This one is with 24. Again, 24 nickels. Look at the rubber band, the amount of time to go up and then back down. Yes, you're all tall for about an hour and 30 minutes. All right, I'll do that one more time. So the amount of time to go there and back. Again, just kind of try to, from the video, see when it goes up until it returns back to where it went. And the seconds were off a little bit there. One last time with 24 nickels. All right, that was 24. We'll try with 32. Ugh. Can't get all of this and still reach. All right. 3, 2, 1. We'll do that one more time. Again, just look at the rubber band. This is 32. There, up and down. All right. And then the last one I'll do is with 40. 1, 2, 3, 4, 5, 6, 7, 8. Again, try your best to get good data. Obviously, I expect some things of this to be off. I care more so about how you're analyzing it than how well the graph ends up looking, because I know there's going to be some difficulties. So this is the last one with 40 different nickels. So can you even see the... There we go. 3, 2, 1. I'll do that one more time. All right, so just do the best you can on that one again. More so about the graph. We couldn't see the timer. Yeah, hopefully you can see it inside of the actual video. Again, just do your best. All right, this next one is the one I like the most. You're going to be calculating the mass of the Earth with a pendulum, obviously. Can we, what? 1 second an interval for 0.1 seconds? What do you mean by that? 1 second an interval for 0.1 seconds? It won't, it's not like that though. So no, you can't just do that. You can't just make up the numbers. I still want you to try to use the numbers as well as you can, even though it's not ideal. All right, so this next part, we're going to be looking at a pendulum. So we have this right here. This green ruler, it's set up to where it's about 30 centimeters from where the pendulum starts until we get down to this blue ruler. And then I've lined these up to where they're overlapping correctly. So our pendulum, where are we looking at on our pendulum? So where do we end our length for the pendulum? Top of the mass, bottom of the mass, middle of the mass? So center of mass. All right, so we're going to the middle. So again, we have 30 centimeters from here to here, and then down to the center of the mass. That's not the mass. There's the mass. So we're trying to go from the center of this mass to here. I'll give you a second to try to read that. Today is pajama day. Yeah, I saw something about that. I didn't see what all the other days were. I think they also had like twin days. All right, so about 15 on the second ruler. So put that together with the 30 on the first ruler. And my thing just fell apart. All right, so centimeters. So obviously you need to put that in meters. Give me 1 second. Yeah, I figured the blue ruler was hard to read, but you should see what the green ruler looks like on video. So yeah, I'm sorry about the difficulties reading the values, but I'm just kind of using what I had available at my house. Using your pencil to color in the number, yeah. Well, no, I have a blue and a green ruler. I like really was considering making my own out of a bunch of paper, but that seemed like a lot. All right, so here's our setup. You're going to have to kind of go back in and look at this. I'm going to pull the pendulum back about 10 degrees and let go. So when we look at it, it's already going to be moving. Let's move you out of the way. So I pulled back a little bit further. I know the black is a little bit hard to see, but you can see when the string stops. All right. So you're going to use that value. I gave you some other values, and you're going to calculate the mass of the Earth, obviously. And I'm intentionally not giving you the mass of the hanging mass. What do you mean parallel rubber band? Yeah, so if you added another rubber band, it would increase the spring constant. The rubber band isn't going to behave perfectly, so it's probably going to be a little bit more complicated than just doubling the spring constant. But yeah, it will affect the spring constant. All right, was everyone able to see the pendulum moving? So it did start moving a little bit circularly. That's not going to affect the value. As long as you see where it starts and ends, it should still be good. It's not going to change it significantly. Any other questions on this one? So yeah, that was all the data we had to look at. Does anyone want me to redo that one again? Yes. All right. We'll do this one more time. Stop. Reset. So it might be best when you look at it, kind of see the time whenever it starts and then look at 10 cycles to complete itself. Let's try to release this sideways this time. So you can try counting 10 of these. Yeah, that was my plan, was to try to use multiple springs, but I didn't have. I had some springs that I was trying to use, but they didn't work very well. I suspect the rubber band isn't going to be very well. Yeah, one count is from the original position and back. So a complete cycle is one there and back. Let's actually look at what that looks like on here. So there and back is one cycle. So if I release from here, 1, 2, 3, 4. And you probably wouldn't count out more than just one of those, like count out 5 of them and see how much time it takes. But yeah, if I had better springs, I was planning on testing it. Unfortunately, I don't. And I don't want to go to Home Depot just for springs and risk other people getting contaminated or anything. Any other questions? Achoo. We only take risks. I mean, yeah, I think for a lot of younger people, we're more likely to not get any sort of symptoms. So it's kind of best to just assume that we have it to not spread it to other people. Yeah, I'm sorry I don't have better springs to do this with. You're welcome. So that was all I really needed to do, was to go through that. So if you want me to redo anything, just ask me to redo it, or I can just kind of wait around for another 30 minutes and answer y'all's questions while you work on this. And yeah, so any other questions on the lab real fast? Animal Crossing. I've never played Animal Crossing. Where will the video? This will be uploaded to YouTube, and I'll post the link in Google Classroom. It'll take a little while. It takes about like 15 to 30 minutes for it to process on Google Drive where it gets sent. Then I have to download it and upload it to YouTube, and that's going to take a little while to actually fully process. So yeah, hopefully about an hour after each stream, they'll be up on YouTube. Do you need a partner? I want you to try to do this as a partner. I really want you to try to do this in groups of 3 or 4. Partly because it's a little bit easier to grade all of them, but also partly because I want y'all to still be collaborating with each other. So yeah, I do want y'all to try to get into a group of 3 or 4. Cat. I started the stream with the cat. He's right here in his window. Don't have a ruler for what? He's kind of preoccupied hunting for birds and insects at the moment. They actually do have rulers that you can print that are to scale if you print it.
Mr. Beverly, it snowed yesterday. You want to see?
Sure, snowed where?
In Minnesota. Let's see.
Is that where you're at right now?
Yeah.
I was about to say that's not too abnormal for up north where it to continually snow.
That's crazy.
Yeah, I wish I was somewhere where it actually snowed.
I've never seen snow before. No, I'm kidding.
What's that?
I said I've never seen snow before. But that was a joke. I actually have seen snow before.
Yeah, and when I was in Virginia for the Navy, it snowed like 2 feet on us. That was pretty cool.
Kali, I don't know. I would just be wary about sharing
Also,
any
I
information
made it through
because,
both streams going at the same time.
We don't know. We don't know.
Nothing stopping me.
Okay?
Yeah, I mean, it depends on how much information we're going through. I didn't put a whole lot of information all at once. Are there any other quick questions about the lab? Other than Daniel showing his whatever that was. So yeah, you're using the data that was recorded in the video. So you're just using my numbers, yes. You're punching the bear. So yeah, you're just using my numbers. I don't expect you to have this at your house. If you do have some things like springs, you could try to like take apart a pin with a spring in it. I tried working with those. They don't work very well. Pair abuse. What does it mean by roles? So when you do this, I'm assuming that you're probably going to split up the work somehow. Like someone could say, if you all gather data, you could say gather data for each person. If one person's role was more writing everything out nicely, they could write that. If one person's role was more doing the math, you could write that. So just kind of saying what each person did. How do I feel after 1 week of quarantine? Well, I'm kind of an introvert, so this is all nice. I don't mind it so unbearable. I don't mind it so much. It's kind of nice not having to commute. Yeah, time has kind of moved a little bit slowly. It's only been 2 weeks since the beginning of spring break. I don't know. I kind of honestly look at how long it took China to shut down. Nick Casper. Yeah, I'm sure everyone is posting a lot of work today. So the only work you're getting today, that was the other thing that I kept meaning to mention. So you got posted this lab that's going to be due next class. The other thing is I did post a review for the upcoming test. Your test is probably going to be early next week, and I'm going to post on Google Classroom. And it will be randomized somehow to kind of minimize cheating. So yeah, expect that. I posted the review to that. That's on the College Board website. Yeah, I don't know what all classes are posting. I'm sure everyone is trying to post. Yeah, I assume everyone is going to try to post assignments. One thing that you can do if they didn't have a Google Classroom before this week, or if nothing you did was online, the teachers aren't allowed to assign grades this week. So if you have any classes where they didn't do any work online yet, or any sort of classroom or anything, you actually don't have to turn anything in this week. But that might not stop them. They might just keep going through it. So yeah. Yeah, that's why this is all getting recorded. I'll take advice if y'all are wanting it at a different time. It would be difficult to do it earlier. I don't know when else I would do this. But yeah, so things coming up. You'll finish this lab by next class. I will have tutorials tomorrow afternoon. I'll post the exact time in case they're changing times up. You do have the review. It's on the College Board website. Finish that. Finish up any of the homeworks and the warm-up from last week. That'll be due tomorrow after school. Any other questions? Next class is Wednesday. Yeah, next class is going to be Wednesday morning at 10. unless for whatever reason it works better at a different time. Yeah, we're just going to keep working through materials. Next tutorial will be tomorrow. I think I said at 1. We'll see. Hopefully at 1. If the time changes, I'll post that'll change. So yeah, we will have tutorials tomorrow at 1. You can ask questions about the lab or the review that's posted on College Board, or I guess the assignments are due at night tomorrow, so any of the random assignments due. Take-home test, that's due today, so make sure you get your take-home test in. The classwork and homework, get that in. The AP classwork, I think it does lock. I can go back and unlock that on some of them. So yeah, on those, don't turn them in because I can make it turn it in automatically for you. We have already covered every AP test topic that they're going to test on this year. Yeah, so classwork was supposed to be turned in last class, but a lot of people, I think one class I let them have another day, and then some people are trying to get in late. So just, if you already have a grade for that in Skyward, you don't have to turn anything in for the classwork and homework. AP test, I'm pretty sure they're still pushing for that to be in early May. It looks like from what they're saying, you're going to get a 45-minute free response test. They are going to check for plagiarism. So I wouldn't just pull up a website and write what's there. If you just try to write what's on a website, you're just going to completely fail it. And I'm pretty sure it's going to be set up in a way where you have so much to do in 45 minutes that's really hard to copy anyways. So I wouldn't be looking at websites while you're doing it, but obviously they can't stop you from like looking at the equation sheet you normally have with like certain notes. But yeah, don't try to copy. Don't expect to just be able to like pull it up and then ask other people what the answers are, because I'm pretty sure you're all getting different questions. Google Meets during the AP test. I don't feel comfortable doing that. I'm not going to help you during the AP test. I don't think they can stop you. I mean, they obviously can't. They're probably going to have a lockdown browser, something like that, that makes it difficult to do other things. They probably, I mean, any papers you have outside, I can't see how they would say you couldn't use them. I'm not going to encourage you to use it because they'll probably have some sort of honor statement that you aren't using external materials. So I'm not going to tell you, hey, do this, do that, but I don't think they can stop you from using your own equation sheet that you have. It sounds like they're trying to do it at the same time in May. What if it's in a tab and you accidentally close it? I do not know. I have no idea. The AP reference sheet, that'll probably be in there with it. They'll probably have it on some sort of thing. I assume it's just going to be each of the questions, and then that will be at the top or the bottom with it. I obviously don't know how the reference sheet is going to look, but you definitely will get a reference sheet. If not, just have yours out. But yeah, College Board, they just kind of put out not like super specific details. The only information I have is from the page that I already sent you. So the only things I know for sure is they're not covering the 3 topics we haven't covered yet. They're not doing waves, they're not doing electricity, and they're not doing the electric force. And they put moving sofa problem on the test. Yeah, so there's a good chance that it's probably not going to make you download an app or anything, but there's a good chance that they'll make you pull up a certain tab that can tell if you're clicking in and out of tabs. So I wouldn't do that. I don't want to like try to tell you how to cheat, but please don't try to do that flipping through tabs, but you do have these things called other things. Just use your phone. Again, when you do the test, please don't just be looking at a website. If you just look at a website and you try to like answer the question while you're doing it, you're going to plagiarize. Like, I almost guarantee if you look at the test and you're looking at a website while you do the test, I almost guarantee you're going to plagiarize and just automatically fail the test. So don't do that, I would say. Score a whole 20. I'm pretty sure they're still going to give you NIMSY money. It's already set up like that. It's going to be official through College Board. The colleges said they would give credit for this test. So assume that's going to happen like normal. Yeah, I would say I wouldn't try to expect to be able to look up everything during the test, though. Just that's how open book tests. Everyone thinks that they can go through and do the test and figure out everything immediately, but that's not going to work very well. I do not know what grade you're going to need for a 3. It's probably going to be normal, like about a 40% for a 3. I don't know though. So, not certain about that. If I figure out more about that, I'll tell you. I honestly don't think they know. I doubt they've fully worked out the amount of points everyone needs. And I assume everyone's going to be getting completely different questions. Yeah, they're probably going to change according to the final grade. Yeah, and there is no multiple choice. So, yeah. Yeah, so you do have to do free response. They are going to check for plagiarism, and trust me, they will be able to detect it if you plagiarize. So I wouldn't try to do that. So if you're trying to do something, honestly, they probably expect people to write some things down. So if you're going to do something, I would write everything out in your own words. Like, please don't try to just pull up the website and test. Do we still need study hours for the test? I'm assuming not. I'm just going to go with that. Honestly, like, I'm not going to try to deal with all those hours and everything. So if they make me do it, I'm probably just going to put the hours in anyways, as long as you've been going to class. One of the curves, hopefully today. I'm going to try to do that right now, get everything in. It's been a little bit messy. Tan, I'll look at yours in a second. What's my best cheating advice? I hate open book tests. I personally don't like being able to look things up because it slows me down. So I wouldn't try to cheat. Showing work with math, I think you're just going to have to try your best. Use like the different symbols on your keyboard. Normally the AP test isn't really insane math, so you're just going to have to try to do your best. Is this going on YouTube? Yeah, this will be on YouTube in about an hour. Is that a question from the website, the College Board website? Or are you just asking a random question? Oh. Radius 6 meters, rotating. Why are you not pulling up? Rotating steadily, Bob standing still on the ground, 0.12 meters from the center of the carousel. I mean, they should, if they're seeing them move directly towards them, I assume they're moving tangential at that time. I'd have to see a picture of kind of what you're saying, but I think it should be the same. Yeah, the test, you are going to take pictures and turn it in. So some people were able to scan it and put it all in one. If you're not able to do that, there's a 20 attachment limit, so you're going to turn in each section one at a time. Yeah, I think it should also be 1 meter per second based on how you set it, because if they're moving towards that point, if they're moving directly towards them, it should be looking at the tangent point, unless you meant something else. Any other questions? They said it's not 1 meter per second. Rotating a radius of 6 meters, standing still on the ground, 12 meter from the center. Oh, from the center. Bob standing on the ground. They're probably getting at the fact that they're moving and the merry-go-round is moving. Yeah, so it's probably something to do with that. Yeah, I'd have to look at it again. If you don't mind actually posting the exact question, I would look at it. But off the top of my head, I don't see it immediately without like working it out. So yeah, if you post a question under the stream, I'll try to work it out. Yeah, so 3 places to turn in the lab. So the self-evaluation, that's going to be the last thing you turn in. That's saying how each member of the group worked. So you have an individual part of the lab at the very bottom where I'm asking you to write a procedure. So that's the individual part. And then you have the group assignment where you do the part 1 and part 2. The lab, this all posted on Google Classroom. That should be due at the end of the day on Wednesday. So yeah, all the due dates are listed in Google Classroom. You haven't been getting notifications. Look on Google Classroom. It should show you when they're due. Go onto the classwork tab and it shows all of them. I know I have a lot of different things. So honestly, if you're turning in most things and I see you miss something and then you turn it in later, I'm probably still not going to count it late until you kind of get a hold of it. Because yeah, I have been posting a whole heck of a lot. And I'm trying not to post so much, but then there's also just, I don't want to not get information out there. So. All right, I think I'm gonna stop recording right now, and then, but you can still stay here and ask questions.